Right, so you guys just did passage number 17, and what we want to go over is the major concepts covered here, the question types, those question subtypes that might come up. This is a great example of an MCAT passage because this is what I like to call a textbook excerpt, right? You're going to have different portions. You have like some stuff on like alpha change, which is like molecular biology. You have physiology stuff like hydroxyapatite, and then parathyroid hormone. And you get some new information in the form of like things like rank, rankle, and OPG that come up in that fourth paragraph. So as we're going through the passage, remember it's really, really important. You just read the entire passage the entire way through, right? In paragraph 1, you're told about collagen, that collagen is particularly important. In paragraph, and then you're given a figure of collagen, the triple helix of collagen. And in paragraph 2, you're told about the different alpha chains that are used to build the different types of collagen. And then in table 1, you're shown the different types of collagen. And then in paragraph 3, you're told a couple of different things. You're told about collagen fibers, and you're also told about bone salts. They mention hydroxyapatite, as well as the chemical formula for that. That's where the majority of calcium and phosphorus are held. And then at the very end, it tells you that in mature bone, approximately 1 to 2% of the calcium salts remain in amorphous form. That is that they're not hydroxyapatite. And that allows for the rapid mobilization and absorption of calcium into the extracellular fluid when needed. All right. So that remember, when you're reading through this entire passage, you want to read every single sentence because you're going to find that particular part becomes important later. Paragraph number 4 talks about parathyroid hormone and calcitonin, right? And in the paragraph, it doesn't tell you what it does, but remember, you need to know all these hormones by heart. So we need to know what parathyroid hormone and calcitonin do. What does PTH do? What is it? So what are these for? Parathyroid hormone and calcitonin. What do they regulate? Bone concentration, blood concentration of calcium. Absolutely. So parathyroid hormone, increase or decrease blood calcium?
Increase.
It increases blood calcium concentrations. Okay? And it does that in one of two ways, right? It does that by affecting the bone and by affecting the kidneys, right? So what does it do to the bone? Increase or decrease bone reabsorption?
Increase.
It increases bone resorption. And it does what to the kidneys?
Increase renal reabsorption.
Yeah, absolutely. So it increases renal reabsorption of calcium. Fantastic. That's how parathyroid hormone works, and then calcitonin works in the opposite way by decreasing blood calcium concentrations. Okay. Finally, we are introduced to rank, rankle, and OPG. And the new information given here is that rankle binding causes osteoclast maturation. And OPG, or osteoprotegrin, it inhibits rankle binding. Rankle binding to rank. Okay. And that's the new information given. That's all introduced in figure 2 in the very end of paragraph 4. All right. So, question number 1. Current research into the treatment of osteoporosis suggests that high pulsatile concentrations of PTH can be effective in building bone. It's hypothesized that this may occur by inducing negative feedback of endogenous PTH with a subsequent increase in both calcitonin levels and calcitonin-mediated effects. Which of the following, if true, would disprove this hypothesis? A patient treated with high pulsatile PTH levels failed to demonstrate an increase in bone density. B, a patient treated with high pulsatile PTH demonstrates an increase in bone density as well as increased renal reabsorption of calcium. C, a patient treated with calcitonin fails to demonstrate an increase in bone density. And D, several patients treated with high pulsatile levels of PTH demonstrate varying increases in bone density. So A and D are probably the most similar of these, right? A is saying that when you give them the treatment, they fail to respond. And D says that when you give people the treatment, that some respond and some don't respond. Do either of these necessarily disprove the hypothesis that we can induce a negative feedback of PTH and then have an increase in calcitonin and calcitonin-mediated effects? Do they necessarily disprove it, or they simply not prove the hypothesis?
Not
Those are
prove it.
Yeah, it doesn't necessarily prove the hypothesis, but that's not the same as disproving the hypothesis. And that's a really important distinction to make on the MCAT. All right? B says that patients are treated with a high pulsatile level. So we should actually be able to eliminate one of these right off the bat. All right? We can't necessarily eliminate A and D just yet, but we can eliminate C. Because C says that a patient treated with calcitonin levels fails to demonstrate an increase in bone density. That doesn't necessarily disprove the hypothesis that if we treat them with high pulsatile levels of PTH, that we can get them to increase their bone density, right?
Yeah.
Okay. So like C, that one goes out the bat really, really fast. And then we're between like A, B, and D, right? A and D are very similar, but A and D actually never disprove the hypothesis. B, on the other hand, says that high pulsatile concentrations demonstrate an increase in bone density, right? Which would make sense to us, but also an increase in renal reabsorption rates of calcium. Now, what the hypothesis says is that we're decreasing endogenous levels of PTH. So if we're decreasing endogenous levels of PTH, would we expect to see an increase in renal reabsorption?
No.
No, we wouldn't, right? So that doesn't correspond with the hypothesis that we were expecting. That makes B the right answer. Question number 2. The formation of collagen requires a large number of enzymatic steps. Mutations in the enzymes involved in these pathways lead to abnormal or no collagen formation. Osteogenesis imperfecta is one such disease characterized by weak bones that fracture easily. Which of the following collagen types is the most likely to be involved in this disorder? So this really, just jump back into the passage, look at table 1. Which collagen type is the one that's associated with bone formation?
A.
Yeah, it's type 1, right? This should be easy, right? These are easy points. Jump back into the passage, figure out the answer, move on, saves you time. Question number 3. Given that most cases of osteoporosis are seen in postmenopausal women, all of the following could be effects of estrogen except. So in postmenopausal women, do we expect estrogen levels to be high or low?
Low.
In postmenopausal women, we expect estrogen levels to be low, and this is basically saying that low estrogen levels will cause osteoporosis. So the question here is saying that which of the following could be effects of estrogen? Estrogen levels will then increase or decrease bone density. Do we expect them to increase or decrease bone density if we have high estrogen levels?
Increase.
Yeah. Estrogen should have some effect of increasing bone density. And so that's what this question is asking us to do, right? It's not a passage-based question at all. It's asking us to use reason for these not and except questions. So would we expect, if estrogen, high levels of estrogen are supposed to have high levels of bone density, increased levels of bone density, then would we expect them to cause the release of parathyroid hormone?
Can you repeat that question?
So if we release parathyroid hormone,
Yep.
then what does that do to bone density? Increase or decrease it?
Decreases it.
Right. So are high levels of estrogen likely to stimulate PTH?
Yes. High levels of estrogen, no.
No, right? Because
Low
high
levels.
levels of estrogen we expect to have increasing bone density, and that would mean we wouldn't necessarily increase PTH levels, right?
Yeah.
Which means A is our answer. And the other answer choices don't make any sense, right? If we stimulate the production of osteoprotegrin, so for example, like estrogen has a bone protecting effect, right? Would it make sense that estrogen stimulates the production of osteoprotegrin?
Yeah.
Yeah. Would it make sense that it inhibits osteoclasts that break down bone?
Yeah.
Yeah. And would it make sense that it inhibits the mobilization of amorphous calcium salts? Yeah. 4. The primary effect of parathyroid hormone is most likely to A, stimulate the production of osteoprotegrin, B, dissolve hydroxyapatite, C, mobilize amorphous calcium salts, or D, decrease renal reabsorption of calcium. So parathyroid hormone, it increases bone resorption and increases renal reabsorption rates. So which two of these answer choices can we eliminate? We can eliminate A, right?
Yeah.
Because it's not going to stimulate the production of OPG. OPG would protect bone, right? And PTH is going to destroy bone. And D, decrease renal reabsorption rate. We know that that's just not true, right? That PTH will actually increase renal reabsorption. All right. So then between B and C, dissolve hydroxyapatite and mobilize amorphous calcium salts, well, that's that new information that we were given down here in paragraph 3, right? Where we were told that 1 to 2% of the calcium salts remain in amorphous form, allowing for rapid mobilization, right? So between B and C, C is our answer because PTH is going to affect the amorphous calcium salts that are ready for rapid mobilization. And 5, various mouse models are used to study the effects of OPG and rankle on the development and treatment of osteoporosis. Based on the information presented in this passage and in Figure 2, which of the following statements is true? A, rank-deficient mice produce severe osteoporosis due to increased osteoclastogenesis. So if they don't have rank, are they going to produce osteoclasts? If they don't have rank, do we ever get the osteoclast maturation?
No.
No, right? So we would not have increased osteoclastogenesis. That doesn't make any sense, right? B says that OPG deficient mice develop severe osteoporosis because they have a decreased inhibition to rankle. Does that make sense?
Yeah.
Yeah, that makes perfect sense, right? If we don't have OPG, then rankle will always bind rank, and we'll always have osteoclast maturation. C says that rank-deficient mice develop severe osteoporosis only when treated with soluble OPG. That doesn't make any sense. And D, OPG-deficient mice with osteoporosis can be treated with soluble rankle. Again, doesn't make any sense, right? Okay, so B is our answer.